Okay, we're going to look at something called double angle trig equations. This is new and is a bit of a leap from the previous stuff that we've looked at with trig equations. The first thing that I'm going to introduce is some formulas for things that we call double angles. Now, we've seen triple angles, quadruple angles, we've seen double angles before, and I've described them as such in these videos. A double angle would be when you double the angle x to get sine 2x. Now, something that is true is that sine x equals 2 sine x times cos x. Okay, now that is a proof in higher maths, and it's something that we're going to prove a wee bit later on in this topic. After we get on from the trig equation stuff, we'll look at trig in a bit more detail, and we'll look at some proofs in trig that can be shown quite easily by doing some simple maths. Sine 2x equals 2 sine x cos x. Now, an important thing to say just now is that is in the formula sheet. Okay, sine 2x is equal to 2 sine x times cos x. And what's also true is that cos 2x is equal to 2 cos squared x minus 1. It's also equal to 1 minus 2 sine squared x. And it is also equal to cos squared x minus sine squared x. And those three will also be in the formula sheet. Okay, now what are these about and where did they come from and what significance do they play in trig? Well, that's something that we'll come on to a wee bit later, but we're going to use these for the time being, which is that if I've got sine 2x, I can substitute that in and call it 2 sine x cos x. If I've got cos 2x, I can sub in and call that 2 cos squared x minus 1. I could also call it 1 minus 2 sine squared x. I could also call it cos squared x minus sine squared x. Okay, now I'm just going to keep these at the side, and we're going to refer to these today in the questions that we're going to look at. Okay, let's get right into it. Let's solve an equation. So we're going to solve a double angle trig equation. So that's a trig equation. Well, let's get three things really. It's an equation, it's got an equal sign, there's some trig element to it, sine or cos, and it's got a double angle. So let's solve this one, this double angle trig equation. Sine 2x minus cos x is equal to 0, and we can see then that there is the double angle, there's some trig terms in this equation, so I would describe that as a double angle trig equation. Okay, now when you've got a double angle trig equation, what you look to do is make a substitution. Now what we do know is we know that sine 2x is equal to 2 sine x cos x, so I'm going to use that fact and I'm going to make that substitution. Sine 2x is equal to 2 sine x cos x, so where I see sine x, 2x here, I'm going to replace it with 2 sine x cos x. I've still got my minus cos x, and that's equal to 0, and I should have said that we're looking for solutions that lie between 0 and 360. Okay, now we can see here that we've got a common factor. We've got cos x and cos x here, so what we could do is take out a common factor. The common factor there, the highest common factor is cos x. Cos x multiplied by what gives me 2 sine x, cos x multiplied by 2 sine x. And then cos x times what gives me cos x, well that'd be a 1, and there's that minus in the middle. Okay, so what we've got now is that's equal to 0, and that is equal to 0. Okay, so let's put a line down the page then. And we've got, first of all, on this side, cos x is equal to 0. Let's get the cast diagram up. And on this side, we've got the fact that 2 sine x minus 1 is equal to 0. Okay, right. It's a non-calculable equation. X equals cos inverse 0. So what's my exact value for that? So from my gathered exact values, my 15 exact values, I know that answer is 90 degrees. So that's the all quadrant result. I'm also in the cosine quadrant. For the cosine quadrant then it's going to be 360, take away that 90, and that will be 270 degrees. Okay, over here I've got 2 sine x is equal to 1 and sine x is equal to 1 over 2. So I'm going to be in the all quadrant and the sine quadrant. X equals sine inverse 1/2. The exact value for when the sine curve's equal to 1/2 is 30 degrees. I'm also in the sine quadrant, which is going to be 180, take away 30 degrees, which is 150. Okay, final move, get my 4 answers, put them in numerical order: 30, 90, 150 and 270. Final answer. Let's just summarise what we did then. Okay, first of all, what have we got? We've got a double angle trig equation. Now, to solve a double angle trig equation, I must make a substitution. Now, I've only got one option here, which is that sine 2x is equal to 2 sine x cos x. So I use that fact. So sine 2x, I replace it with 2 sine x cos x. I then look to take out a highest common factor. So from here, what's that? That's cos x. Cos x multiplied by what gives me 2 sine x cos x, 2 sine x. And cos x, there's a minus in the middle. Cos x times what gives me cos x, that's 1. That times that equals 0, which means that's 0 or that is 0. So split the thing up. Cos x equals 0. Follow what you've already learned. 2 sine x minus 1 equals 0. Bring that over. Follow what you've already learned. And it's a non-calculator exact values equation. Let's try an example 2. Okay, example 2. Let's go for... We're going to solve sine 2x minus 3 sine x equals 0. Solutions that lie between 0 and 360. Okay, so let's just confirm again. A double angle trig equation. I'm going to use that substitution. Sine 2x equals 2 sine x cos x. Where is sine x? Sine 2x rather. I'm going to replace it with 2 sine x cos x minus 3 sine x is equal to 0. Okay, let's look for my common factor. Okay, highest common factor this time. I'll look for a number, but I won't find a number bigger than 1, but I will certainly find sine x. Okay, sine x multiplied by what gives me 2 sine x cos x, that's 2 cos x. There's a minus in the middle. Sine x multiplied by what gives me 3 sine x, that's 3, equals 0. Okay, that equals 0. Of that equals 0. Split the thing down the middle. Sine x equals 0. Cast diagram up. Okay, I'm going to be in the all quadrant and the sine quadrant. X equals sine inverse 0. When's the sine curve equal to 0? That's one of my exact values. That is 0. Okay, what about in the sine quadrant? In the sine quadrant, I do 180, take away 0. That's 180. 0 and 180. Okay, over here, 2 cos x minus 3 is equal to 0. Bring that over. 2 cos x is equal to 3, and cos x is equal to 3 over 2. And let's get a cast diagram up. Okay, so this time I'm going to be in the all quadrant and the cosine quadrant. This going to be my next line. So x equals cos inverse 3 over 2. At that point, what I should find is with or without a calculator. With a calculator, that's going to come up as maths error. But even without a calculator, I should realise at that point that I'm not going to get any solutions. 3 over 2, that's bigger than 1, that's 1.5. The cosine curve only goes up to 1 and minus 1. Therefore, what I say at that point is that I get no solutions. Okay, example 3. Right, example 3, this time I've got cos 2x plus cos x is equal to 0. Okay, I've got another double angle trig equation, which means that I'm going to use one of my substitutions. Now I'm not going to then start to look at this formula here, which is sin 2x equals 2 sin x cos x, because I don't have sin 2x, I've got cos 2x. So I should drift over here to these three. Cos 2x equals 2 cos squared x minus 1. Cos 2x is equal to 1 minus 2 sin squared x. And cos 2x is equal to cos squared x minus sin squared x. Okay. Now, just as a wee hint to get going here, in trig equations, you rarely use this one. It's not to say that you never use it, but it's rare that you use that one. Most popular are to be using this one and this one. Now, which one should we use then? That's a decision to make. We'll take a note of this just now in your jotter, because here is how you make the decision. Let's write a note on this just now. Use cos 2x equals 2 cos squared x minus 1 if cos x also appears in the question. This is a really important note, make sure you get it down. Use cos 2x equals 1 minus 2 sin squared x if sin x also appears in the question. Okay, so let's look at this example then. Cos 2x plus cos x equals 0. Okay, so I'm going to think, right, I rarely use this one, so it's going to be this one or this one. So I'm either going to use that one for cos 2x or that one for cos 2x. Use cos 2x equals 2 cos squared x minus 1 if cos x also appears in the question. Use cos 2x equals 1 minus 2 sin squared x if sin x also appears in the question. So if I've got cos 2x and I've got cos x, that means that I should follow the first piece of advice. Use cos 2x equals 2 cos squared x minus 1 if cos x also appears in the question. So that's the formula that I'm going to use. Cos 2x is equal to 2 cos squared x minus 1. I've still got my plus cos x, and that is equal to 0. Okay. Now, I'm now going to put this in just what I would describe as a slightly more suitable order. 2 cos squared x plus cos x minus 1 is equal to 0. At that point, I think we can start to do a wee bit of the work that we did a few periods back, which is we're going to liken 2 cos squared x plus cos x minus 1 equals 0 to 2x squared plus x minus 1 equals 0. Okay, it's then 2 times minus 1 is minus 2, and I'm looking for two numbers that multiply give minus 2 and add together to give 1. That's going to be 2 and minus 1. Okay, so that's going to be plus 2 and minus 1, and I'll drop the 2x in here and drop the 2x in here. The second bracket cannot be factorised further, however I can take out a common factor at 2 here and bring that down to x plus 1 bracket 2x minus 1 equals 0. Let's bring that back in then, so that's going to be cos x plus 1 bracket 2 cos x minus 1 bracket is equal to 0. Okay, right, so I'm going to take this now and put a line down the page, and I've got cos x plus 1 is equal to 0. I should have said at the start solutions between 0 and 360. And over here, 2 cos x minus 1 equals 0. Okay, bring that over. Cos x equals minus 1. Let's get the cast diagram up. As discussed before, these questions are multi-layered. You just need to make sure that you're accounting for everything on all the layers as you go and remembering each part. Okay, so if cos x equals minus 1, so I know now to take care of one of the other steps, which is to change that to positive, and then look not in all in cos, but in sine and tan. Okay, x equals cos inverse 1, so that's one of my exact values then. So when is the cosine curve equal to 1 at 0 degrees? However, that is my all quadrant solution, so what I need to do then is to cross that out. I'm in the sine quadrant, which tells me to do 180 minus 0, that's 180. And I'm in the tan quadrant, which tells me to do 180 plus 0, which is also 180. I don't need to write that down twice. Okay, let's pick up this side. 2 cos x equals 1. Cos x equals 1 over 2. Okay, so I'm in the all quadrant, cosine quadrant. X equals cos inverse 1/2. That's an exact value. 60 degrees, that's my all quadrant result. That's fine, I'm in the all quadrant. And for the cosine quadrant, it's 360. Take away that 60, and that's 300 degrees. Final thing, let's put it all in order. 60 degrees, 180 degrees, 300 degrees. Final answer. Okay, let's try an example 4. We're going to solve cos 2x minus 7 sin x is equal to 4, and we're going to look for solutions that lie between 0 and 2 pi. So here's an extra variable we're thinking about while working with radians. Okay, first move, let's bring that across, change its sign, let's get that done, that's easy. Cos 2x minus 7 sin x minus 4 is equal to 0. Okay, let's look at our race again. Use cos 2x equals 2 cos squared x minus 1 if cos x also appears in the question. Use cos 2x equals 1 minus 2 sin squared if sin x also appears in the question. Right, so I think that's pretty clear then. We're definitely going to be using this one. So where I see cos 2x, I'm replacing it with 1 minus 2 sin squared x minus 7 sin x minus 4 is equal to 0. Okay, so I've got minus 2 sin squared x minus 7 sin x. I've then got 1 and minus 4, which is minus 3, and that is equal to 0. Now what I can do now, I've got the thing equal to 0, is I can multiply everything through by minus 1 to get something that's a wee bit more suitable. Two sin squared x plus 7 sin x plus 3 is equal to 0. Okay, I'm then going to liken 2 sin squared x plus 7 sin x plus 3 is equal to 0 to 2x squared plus 7x plus 3 equals 0. Okay, let's do a wee bit of National 5 solving of quadratic equations here. 2 times 3 is 6. Two numbers that multiply gives 6, add together gives 7, that's 6 and 1. Okay, drop the 2x in here, and the 2x in here, second bracket, cannot be factorised further. Write it down again. First bracket, I can take out a common factor at 2, brings me down to x plus 3. So let's bring that back in, so it's going to be sin x plus 3 and 2 sin x plus 1. Is equal to 0. Okay, next move, quite straightforward from here, line down the middle of the page. Okay, sin x plus 3 is equal to 0. And 2 sin x plus 1 is equal to 0. Okay, over here, sin x equals minus 3, x equals sin inverse minus 3, and with or without a calculator won't deal with that, it will tell you it's a maths error, but even without a calculator we should know that. Sine curve does not go down to minus 3, it goes between 1 and minus 1. So at that point, let's score that out and say no solutions. Okay, let's come over here. 2 sin x equals minus 1 and sin x equals minus 1 over 2. Okay, our routine then is to make that positive and to look in not the all in sine but the tan and cosine quadrant. Okay, so x equals sine inverse 1/2, and that is 30 degrees. Just remember, follow my advice here, which is to be careful with the detail. It's a radians question, so I should have been thinking about that with that one. Try it again. Put it in radians. I can think in degrees certainly, but right in radians that's pi over 6. Okay, next move. I'm not in the all quadrant, therefore that is not a solution. I am, however, in the tan quadrant. Now, the tan quadrant tells me to do what? It tells me to move on to add to pi. Okay, so it's pi plus pi over 6. So I've got a pizza plus another 1/6 of a pizza. Well, one full pizza is 6/6 plus another 6. That's 7/6 of that pizza. That's 7 pi over 6. Okay, I'm also in the cosine quadrant. The cosine quadrant tells me to do what? It tells me to move backwards from 2 pi by pi over 6. So it's 2 pizzas, and you're going to eat 1/6. So 2 pizzas, 12/6, eat 1/6. Leaves you with 11/6 of the pizza, 11 pi over 6. And that is my final answer.